The Gina gasket has been able to function for a long period of time while being able to withstand heavy loads during the initial phase. The gasket must counter large compression forces and pressure, compensate for large movements like sediments or earthquakes, and it must be durable both in terms of long surface life and its ability to withstand being submerged in salty water. The compound rubber material we use is specifically designed to function in this environment. It has a high allowable shear movement and a low initial compression force. But because the body is stiff, it can cope with significant forces. It also ages very slowly and demonstrates very little creep.
The construction of the standard Omega seal consists of two nylon plies with synthetic blend rubber cover on the inside and outside. The amount the Omega seal can move depends on the pressure differential across it and the strength of the plies in combination with the size of the seal. The Omega seal must not stretch or its ability to remain watertight might be compromised. We add the square woven fabric to take the force from the water rather than the rubber itself. Generally, it is designed to allow both axial and radial movements or rotation of the two bridged structures. Gap closure and axial movement will compress the arch of the Omega seal. An increase in the gap is limited by the circumference of the Omega seal's arch, and because it has been reinforced, the rubber does not elongate. Vertical movements of the joint causes lateral deformation in the seal. Rotation around the vertical axis of the structures causes compression in one's vertical section and elongation in the other. To increase the movement capacity, the Omega seal can be mounted with pre-compression.
The primary seal between two concrete structures is accomplished by the internal water stop. The water stop is fitted roughly in the center of the wall and bridges the movement in the wall. The water stop has a sponge at its center. The purpose of this central section is to form a free shape in the concrete, which is necessary to allow movement, and the rubber sponge strips being flexible facilitate the fixing of the water stop into the shuttering and create at the same time a perfect seal between the sponge rubber and the shuttering. During the concrete pouring and casting process, no cement slurry is able to drain off owing to shuttering leakage, thereby preventing honeycombing and the formation of cavities in the concrete. The concrete quality in the area around the water stop is critical in ensuring the watertightness. Our newest water stop has the ability to be injected twice with epoxy resin, which might be necessary within circumstances in which the concrete water stop adhesion is low due to poor placement. Epoxy resin is able to fill up cracks and cavities, which result in better watertightness.